Alright everyone, welcome to week 8. We're now halfway done with the semester. And it feels like you don't know how to make World of Warcraft yet. It's normal. We spent the first third of the semester talking about game design principles, and really we could spend the entire semester talking about it. I'll probably give you guys another game review to do at some point, play with your group and analyze it another game, because it is actually really important to talk about the principles of game design. I saw an interview earlier today with the author of FTL and some other games talking about principles of game design. It's really important if you're going to be making games. Right now though, and then we went into materials and landscaping, which will help you make your games look nice. And then we are now going to get into the math side of things, because once you kind of understand the basics of math, and hopefully none of you guys think it's too hard so far, you guys are doing pretty well in this, although a 0% does not lend confidence. Most of you guys are doing pretty well in this. You'll understand the math actually isn't that bad if you know how to do arithmetic. It's pretty straightforward. Up to 350 inches big is the movie theater. What type of graphics card should I get for UE4? Would a GTX 1050 Ti be good? I've used one of those before. I think that's actually what my laptop has. It might be the mobile version of it, and it does okay. All of these questions are like, more is always better. The good news is you should be able to get a loaner laptop now. I believe they're in, or will be in soon. So I just get one of those from the school. But I would say get as good a video card as you can afford. Yeah. RTX 2060, yeah, should be fine. Maybe it's fine. I have a 2080 Ti. I've not been able to get a 3090, despite... Well, I mean, I guess I could pay the scalpers for it, but I kind of refuse to. I don't want to encourage them. So let's see how those 3090s are looking right now. GPUs are space eaters. Yeah, the 2100. Yeah, and it's still out of stock. Like they're literally sold out despite being $500 over MSRP right now, right? So. Yeah. Ridiculous. Yeah, so I'm sticking with my 2080 Ti for now, which is fine. Okay, so the length of a vector of 3, 4 is 5. This is the Pythagorean theorem. 3 squared plus 4 squared is square rooted is 5. So that is how you find the length of a vector. Use the Pythagorean theorem. X squared plus y squared square rooted is the length. If you normalize it, you divide each of the components by the length. So 3 divided by 5, 4 divided by 5, and you get the normalized vector. So that is a unit vector, a vector of length 1. So in order to get a vector of length 1, you take the vector and divide it by the length. Some of you guys put down 5 because 5 is the length. Nope. That is not a vector of length 1. That is a vector of length square root of 50, whatever that is. Not 7.1. So you have to understand what normalize means. Normalize means length 1. Okay. Normalize this vector, so that is 900 plus 3600 is 4500 square rooted. Okay, so 3600 plus 900 is 4500 square rooted is 67. So 30 divided by 67 is 0.44. Yeah. So 3 of you guys did the sign, didn't do the decimals. So make sure you do the decimals. It's 0.44. A normalized vector will be between 0 and 1 or 0 and negative 1 on both of the numbers. This is not a normalized vector. Okay. So what you do is you take the length of it and then you divide each of the components by the length, and that gives you the answer. It's pretty straightforward. We are going to continue this topic today, and we will learn how to backstab people in video games and to tell if a NPC should jump to the left or jump to the right in Cyberpunk. And the answer is, it doesn't matter. It's Cyberpunk. It's buggy as hell. So let's run some OneNote and do a little bit of theory. A little mathematical theory here. Page 3 to 21. Poor Cyberpunk. Yeah, they haven't done anything to fix it since then, really. I don't regret my time with it, but it is definitely not the best that CD Projekt Red could have done. Hope it No Man's Sky. Yeah, maybe, probably. I mean, they've kind of got their studio's reputation on the line. EA canceled Anthem though, so maybe it could go that way too. I don't know. All right, so let's talk about backstabbing. Okay, so let's say that you've got a guard, right, and the guard is looking in this direction. He's also apparently a male because that's the symbol for masculinity. And let's say that you are here. It's you. And you're looking in this direction. And you attack with your knife. So, how would you do this in code to tell A, if you hit, B, if it is a backstab? How'd you guys do this? You can just say it in English if you want. Cyberpunk to Gmod. TF2 does this via 180 degrees. The original Team Fortress was narrower than 180 degrees. You'd have to compare coordinates, alright. Well, let's say they're at 10, 10, and you're at 20, 20. These are world coordinates, obviously. Compare their look vectors. Okay, yeah, for seeing if you hit or if you backstab. What do you think? For backstab, yeah. So it doesn't matter which way the guard's looking. You know, the guard could be looking in any direction. All that matters if you hit is your look vector, right? So you've got a look vector. And they've got a look vector. All right, their look vector doesn't matter for the first part. It does matter for the... Yours does matter for the first part, right? If you're looking at them. It's normally in video games, weapons come out of your camera, right? Would you use an if statement? I don't know. Probably. There's probably going to be an if statement in there somewhere. But how, just describe to me, how would you describe if you hit? Right? You're looking in some direction. It might be at the guard, it might not be at the guard. How would you figure out if you hit them or not? There's at least two things you would need to do. Guard needs not to be looking at you for the second part. Let's just talk about the first part. What does it mean to hit somebody? So let me give you some tools in your toolbox. A is called trace line. And B, you already know, it's called vector length. So using those two tools, sort of blueprint nodes, let's say, which they are, how would you, just, speak English, it doesn't have to be Cody, just how would you, trace line says from a starting point to an ending point, see what the first thing you hit is. Okay. And in IS50B, we learned how that actually happens, and happens quickly, without having to check every object in the world. Be done in order login time, so fairly quickly. You can see who the first person you're hitting is. So traceline takes a starting point and an ending point, and sees who the first person is. First object might not be a person; could be a wall, right? There could be a wall between you. That's one tool, and the second tool we learned last time, which is to tell the length of a vector. Hit scan, yeah, that's exactly what hit scan is. Yeah, it's just it's called a trace line or a line trace, depending on which engine you're using. What do you guys think? How would you write code to see if you hit the guard? Trace a line from your weapon to whatever you look at, and if it hits a player, it's a hit. Well, is the guard a player? Am I being picky? Probably. Dolan, what do you think? How would you code this using these two tools? Figure out the distance you are from the guard, yeah? And then what would you do with the distance? So vector length will tell you distance, right? So you have the guard has an origin, you have an origin, right? Every object has a position. Every object in the world has a direction, right? They're looking. So what you do is you take your position and the guard's position, your position, minus the guard's position, subtract them. Remember, that gives you a displacement vector. That gives you the distance, or that gives you a vector from the two origins. You feed that into vector length, and that will return to you some number. Like, let's say, I don't know, 50 or something. So what do you do with that? They're 50 units away from you. Is that a hit? Yeah, exactly. What is the range of your weapon? I don't know. You tell me. How many centimeters? Because in Unreal Engine, centimeters is the base unit. How many centimeters do you think a stabby stab should be? What do you guys think? There's no right or wrong answer on this, by the way. Just throw out a number. 10 centimeters? This far? 300, so what is that? 9 feet away. Bigger than this. You hit somebody across the room. Long sword attack. Yeah, that's fair. That's fair. 10 centimeters. Javelin, Nerf gun. Yeah. Say we're just doing like a knife attack. Would you normalize it? The displacement vector you would not normalize, because you want to know how far away they are. And so you take their position, your position, subtract them, and then you feed that into vector length, and that will tell you how far away they are. And then you have a if statement in there that says if they're within weapon range, whatever it is you guys come up with, it might be 300 centimeters, it might be 10, it might be somewhere in between. Whatever the range is, and you set that's a game design decision you make, by the way, how far away you can hit with a knife. Knives in video games are often the most powerful weapon, right? For who knows what reason, you throw a little dagger, and it flies across the roof and hits somebody, and they go and they instantly die, right? I don't know why. Like you got all these futuristic laser guns and hyper shields and all this stuff, and in Halo you come up and whack somebody with the butt of a gun, and that does more damage than shooting them. I don't know. Doesn't make sense to me. But yeah, it's just one of those tropes in video games where melee weapons just do unbelievable amounts of damage. It's better to hit somebody with the back of a gun in Halo than the front side and shoot them with it. So yeah, so whatever the range is, it doesn't really matter. It also makes melee weapons balanced, right? Because if, like in the original Quake, there's an axe attack. The axe attack does like 20 damage. You have to hit somebody 5 times with an axe to kill them, and that's if they have no armor whatsoever, right? So the axe was barely used in the original Quake. So in order to encourage people to use melee weapons, they amp the damage way up. Although that is kind of frustrating when you're seeing they're shooting somebody in Halo with a laser gun, and they just come up and go and kill you. It's like, okay. Thought this was a laser battle, not a punchy battle. TF2 is market gardening. Okay, so anyway, so if you want to hit, what you do is you trace line from here to here, and see if they are in fact the first person you hit. Because after all, there could be a wall in here, right? And so you do a trace line from point A to point B, and if they are in fact the first person you hit, cool. And then you got to make sure they're within range. Cool. All right, we've hit them. Step 2, step B, is it a backstab? Okay, so a lot of you guys have the right idea. You have to figure out which way they're looking, right? And so if a guard's looking at you, you can't backstab them, right? It's a front stab. Still hurt them, but a backstab in video games is usually instant death, right, or close to it. So if the spy in Team Fortress backstabs somebody, it will one-shot kill most people, or it should, if they're uber health or whatever, it might not. But yeah, so how do we do that? Well, that's the topic for today. So if you've got a guard, and the guard's looking that direction, and you're here, this is you, and you're looking in this direction, is that a backstab? What do you guys think? Nope. Haburn says no. All right. So the guard can see kind of in this radius. From the side, yeah, it looks like a side attack, you know. But it's an interesting question. Like, is a side attack a backstab or not, right? Because you kind of got 4 quadrants, right? Like you got you know, kind of the back zone over here, which is clearly a backstab. This is clearly the front zone, but the sides are a little iffy, you know. And so this is a design decision, right? A design decision is how wide an angle do you allow backstabs for, and that's something you have to figure out through just playing the game. Get into a game with your friends, try backstabbing each other, and if you land a shot that you feel should have been a backstab and it didn't register as a backstab, then you need to make that angle wider. Whereas if somebody comes up and stabs you in the arm and you explode in a cloud of blood, you're like, dude, that wasn't a backstab, that hit my arm, you know, then you make the thing narrower, right? And so that angle there, and theta is just a symbol for angle, right? It's nothing, there's nothing magical about it. Math people like having weird symbols that confuse people. That's theta. And it just means an angle. You know, it might be 90 degrees, you know, here it might be 180 degrees, you know, whatever. It doesn't matter. I mean, it matters a lot, but, you know, for the purposes of what I'm about to explain, we'll just call it theta. Whatever, there's some angle. Okay. TF2 has face stabs by bugs, yeah. Peripherals, some games are. Razorback and Uber are the only defense against backstabs. Yeah, 180 degrees is a really wide. I mean, that's a huge. I mean, you're talking about that whole area back here as a backstab zone, which to me seems a little bit excessive, but you know, whatever. Spies are fairly easy to detect anyway in the game, so give them something to do. All right, so how do we do this? Well, here are 2 new tools. Dotproduct. So here are 2 new things that we are going to learn today. First is called dot product. Second is called cross product. Okay. These are the 2 things we're going to learn today. Dot product tells you are 2 vectors looking the same way. Okay. And dot product takes normalized vectors, or it should. It doesn't have to, but it should. And so if you've got vector A dot vector B, this will return a number from -1 to 1. -1 means opposite directions. In other words, if the guard is looking at you and you're looking at the guard, that will return -1. Means opposite directions. 1 means the same way. So if the guard is looking to the north and you're looking to the north and you hit the guard, guess what? You are perfectly behind him. Boom. The dot product will return 1. And so what you do is you pass in the guard's look vector. The guard's look vector. That goes in there. You pass in your look vector to here. And then you pass it into dot product, and dot product gives you a number from -1 to +1. If you get a number at or near 1, you are looking the same way as the guard. You are behind him. That is definitely a backstab. If you get -1, that means he's looking at you, you're looking at him. Definitely not a backstab. 0 means side hit. Okay. So in this case here, where we are attacking the guard, this would return a dot product. The dot product of this would be around 0. Okay? And it's not like it returns either -1, 0, or 1. It returns a number in that range. And so most of the time what you'll do is it'll be something like this. So you got your guard, the guard's looking that way, you are looking that way, like pretty close to them, but not exactly. This will return a dot product of like 0.8, something like that. You guys understand? So if it's close to 1, then it's a backstab. Okay, that's how you'd code that. And other examples, guard is looking this way, and you are looking this way. The dot product on this might be like 0.1. Right? It's not perfectly to the side. 0 is perfectly 90 degrees. Okay. So it's probably not a backstab. Unless it's Team Fortress 2, in which case it is a backstab. Because it's like 1 degree behind them, so it counts as a backstab, I guess. Seems dubious to me. And then the other option is the guard is kind of looking at you, and you're kind of looking at the guard a little bit. This might be a dot product of like negative 0.7 or something like that. Definitely not a backstab. He's looking at you. And you can also use this to determine if he can see you. Right? So the same code you use the dot product, the guard, which direction the guard is looking in, and then a vector from the guard to you, that displacement vector we talked about. You dot product it, and then you can tell in your AI code, when you're programming AI code, the guard can see you. With the dot product, whether it be the same, whether you're in front or behind the guard, as long as you're facing in the same direction, it would be. But remember, you only call this after you know you hit them, right? You do a trace line. You do a trace line to make sure there's no wall or anything in between you. So you click mouse. Mouse fires a trace line, hit scan towards the guard. It encounters a wall, miss, right? It's the guard, but it's outside of the range. Miss. Hit scan connects with the guard. Okay, cool. We got a hit. Now we need to find out, is this a backstab or not? So you can't be in front of the guard, because if you're in front of the guard, your attack would miss. Does that make sense? So if you're looking the same direction as the guard and you hit them, then that means you're behind them, right? Unless your weapon fires backwards, which would be a really weird weapon. Pew, 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 and bullets fly out of your ass, like that. Maybe somebody will do that someday. You got a tail gunner or something, right? You're flying a Stratoforce, big World War II bomber with a gun out the back. Maybe you could do that, but probably wouldn't be backstabbing people in that case. So yeah, so those are the 3 circumstances, and basically what you're going to do is you're going to set a threshold, and you're going to say, all right, well, if the dot product is over 0.7, then it's a backstab. Does that make sense? And it's something you just play with your friends, turn on God mode, run around having a knife party, stab each other, just print what the dot product is, and then it's 0.7 seems a little too tight. Let's make it 0.6, make it a little bigger. The thermal thrusters is a backcannon. Yeah. Mathematically, it's the cosine of the angle, right? So if you so 0.7, if we go into scientific and go arc, trig, inverse cosine. No, what happened here? Clear. 0.7 inverse cosine. So that's a 45-degree angle, right? So if you set the dot product, if you require the dot product to be greater than 0.7, then what that's going to do, it's going to create a 45-degree cone coming out the ass of the guard there. It's 45 degrees on both sides, so it's actually 90 degrees, right? And so that would give you a 90-degree arc within which to stab. Okay, and so that's one of those things that it's a game. That number here, it's a game design decision, but somewhere around there, I would say is probably about right. Do you guys understand? And so the dot product is in Unreal Engine. You just I'll show you guys how to do that in a second. You just drag a blueprint out, dot product. You feed in your look vector, you feed in their look vector, and it will tell you if it is a backstab or not. Actually, do you guys just want to see that before we move on to cross product? Okay. Mathematically, let me just show you how to compute the dot product. So if you've got two normalized vectors, the dot product's really easy to compute. So assuming the vectors start at the origin. So let's say you've got this guy here, which is 0.6.3. You've got this one here, which is 0.45, 0.45, something like that. It's not normalized, whatever. If you want to take the dot product of these two things, the equation, this is x1, y1, this is x2, y2. The equation is just x1, y2. Was it times or multiply? Can't believe I'm blanking on this. Yeah, it's just addition. Yeah. X1, Y2. I don't know how I can blank on that. X2, Y1. Right? And so you multiply this number and add it to this number and this number. And that will give you a number from -1 to +1. That's it. Not too bad. Did you guys do that on a quiz? Given two vectors like this, this would tell you, are they looking in the same direction? So in this case, so the dot product is x1, y2 plus x2, y1. That is correct. That is absolutely correct. So in this case, 0.6 times, hello Ada child, right, 0.27. So in this case, the dot product would be 0.4. And it gives the angle, it gives a number from -1, it gives a number from -1 to +1. -1 means you are facing, you're looking at each other. +1 means you're looking in the same direction. And 0 means you're looking at 90 degrees to each other. It's the what it is the dot product is just the cosine of the angle here. So if you have the angle here, the cosine of the angle, cosine of theta, is the exact same thing as the dot product. Does 0 indicate which 90 degrees? Nope. That's what you need.
Is that gun backwards or something?
Yes. We were talking about a gun that shot backwards, and so he posted a backwards facing gun. Yeah, it does not tell you whether they're looking to the right or to the left. That's what cross product is for. So cross product will tell you right or left. Dot product tells you forwards and backwards. Good question. And so with these tools, these building blocks are just used all the time. Like let's say you go up and hit use, you hit the E key, right? It does a trace line. Let's say you're in Cyberpunk, right? You go up, you hit the E key. It trace lines out of your camera, connects with a vending machine. But let's say you only want the vending machine to be usable if you're looking at it. Like if you're behind the vending machine, you don't want it to activate because that's really weird. You know what I mean? So what number would you allow as opposed to everybody in class right now? So let me draw it out here. There's the vending machine. The vending machine's looking this way. That's the face of it. This is where all the buttons are. There's the display area there, and this is top-down view, right? That's where you put your money in or whatever. And let's say that you are here. This is you, and you're trying to activate the vending machine from behind. It shouldn't work, right? It should only work if you are looking at the vending machine, right? So what values of the dot product would you guys allow the vending machine to operate on? What do you guys think? The dot product has to be in what range? Between what number and what number? So you don't want it activated from behind. It's the opposite of backstep, right? You only want it to operate from the front. What do you guys think? Hey, can you grab me like a bottle of water or something once you have your sushis? Yeah, -1 is -1 would be one of the values allowed, but it's not the only value. Because remember, dot product returns a range. It returns a numbers from, there's a whole, it's a continuous range from -1 to +1. So -1 would be allowed, but if you only allowed -1, then you can only activate the vending machine if you're precisely squared up with it, right? Exactly on the right to the 10th of an angle looking at it, it would activate. From 0 to 1, that would so 0 to 1 would be all of this area back here, lobby. And so that is probably not right. Habern says -1 through -0.99, so that would be a 1 degree arc or so. Let's see, what would that be? How many degrees is that? 0.99 inverse cosine, so that'd be an 8 degree arc on either side. So you'd have like a 16 degree arc in front that you would be able to activate it on. So it'd be a very tight 8 degrees. 8 degrees off normal. We need a graph with dot products. Yeah, just it's fine. It's fine. It's the kind of thing you spitball. I would probably allow the thing to be used from a fairly wide angle. You know what I mean? Like if somebody was standing here and looking at it, like I think that'd be fine. Yeah. So I would be fairly tolerant with it. So I don't know what. Maybe a 60 degree arc each way. A 60 degree arc each way is 120 degrees. Maybe not entirely from the side, because from the side would be like down here, and that's kind of weird. If you're like hitting the vending machine on the side, that seems a little weird. Like maybe like a 60 degree arc on either side. Something like that. And so 60 degrees, am I in degrees, am I in degrees, I'm in degrees. 60 degrees cosine is 0.5. And so what I would say is I would say the dot product is between -1 and -0.5. That makes sense? So I would take the look vector of the person. I would take the... Thank you, Wonderchild. I can't eat here, though. Students don't want to see me eating sushi. They already accused me of making ASMR videos. Thank you for the water, though. And so if you're looking at the vending machine, you take the dot product of your look vector and the vector of your position to their position and dot product it. And if you get a number from, in my opinion, -1 to -0.5, it may be right, it might be wrong. You just have to play with it in the game. Now, these things are as much art as they're science. That's one of the really cool things about game development. In computer science, if you get something wrong, it's like, you're wrong. You're wrong. 0. You didn't sort the vector right. You're wrong. I really can't eat in here, girl. Yes, I got you a bunch of Tamago. You are welcome. You are welcome, my daughter. But in game development, it's like... No, just,
thank you.
There's art. A lot of it is just value calls, judgment calls. It's kind of fun, you know? And that's one of the reasons why I like doing game development. It's like you just sit there and make happy little mistakes, you know, and have a bug in your code that turns out to be really awesome. Like my daughter loved the bug that I told her about where it reduced the reload delay on a nuclear weapon from 8 seconds to as fast as you could click. Like a Bethesda level mistake, you know?
Probably my favorite thing about Cyberpunk is the bugs.
Ada's favorite thing about Cyberpunk is the bugs. That's why she likes the game a lot. There were a lot of bugs. So, where did 0.5 come from? Cosine of 60. That is correct. Yeah. But again, it's -0.5, right? Because negative numbers are when you're looking at each other. Positive numbers are when you're looking the same way. So if the vending machine was looking the same way as me, then I'd be trying to put money into its power cable, right, in the back, which I don't want. But if the vending machine's looking at me, then the numbers are going to be negative. And then you have to choose like how wide an arc you can activate the vending machine from. And I just sort of spitballed 60 degrees. I could be wrong, you know. You guys that were saying other numbers, you could be right also. There's no, like I said, there's no right or wrong number. You just kind of experiment with it and see how it goes. So
definitely do not make it. You can click on it from 100 feet away.
you want to be able to click on it from 100 feet away.
No, definitely do not do that.
Yeah. So when you hit the use button, you send a trace line with a certain range. If it contacts it, then you do the dot product, and if the dot product is less than 0.5, then you are more or less in front of it. Good enough for college work, and then it spits out a Coke or whatever. No wonder she likes Skyrim. Ada, do you like Skyrim because of the bugs? No? There was one funny bug, though. We reloaded the game, and there was something underneath where the horse reappeared in.
Mm-hmm.
And so the horse, the physics engine threw the horse into the air. And because the horse wasn't activated, the AI didn't activate, the physics engine didn't kick in on it. And the horse just sat there rising up like this.
Mm-hmm.
Flying horse.
There's another funny one where when I activate the sunstone and the expansion, instead of one locator appearing, 3 of them.
It spawned 3 monsters instead of 1. Yeah. Yep. Classic Bethesda. Yeah. So she got 3 times the loot.
I found a floating shield in a 4 before.
Floating things, yeah. Bethesda has a lot of floating objects in them as well. The physics engine in general as an optimization doesn't run unless you touch it, right? So if there's a bottle that just happened to be floating in air for some reason,
you touch it.
if you touch it, it falls to the ground. But otherwise, the physics engine won't run because it's expensive.
That was the opposite with the horse. Even if I was already riding on the horse, and if I got off, I got off, it starts rising. Wait, what?
It looks like a bug from Skyrim with a corpse floating in a circle. Okay.
How can a corpse is floating in a circle?
It's Bethesda, girl. Like that's just how things be sometimes. All right, it's just how they be. All right, so let's see how to do this in Unreal Engine. And by the way, does this interest you guys? Like learning how to backstab?
Also, a guard appeared once it
like
take. It didn't say steal, and a guard appeared for me taking that.
Okay. 10 out of 10. Excellent. So yeah, in Kingdom Come Deliverance, the guards will yell at you if you don't have a torch at nighttime.
How come?
Because it's the law that you have to carry a torch at night.
Why?
Otherwise, they'll think you're a thief, and so you carry a torch so people can see you. And
how come they don't scold at me though?
I don't know if you've played Kingdom Come Deliverance.
I thought.
But sometimes the guards will bug out and they'll yell at you during the daytime as well.
How come?
It's a bug, and so they'll. Ada, this is why I don't want food in here. Go pick it up. Pick it up. The chopsticks that are on the new carpet. Math is interesting on how it can be applied. Yeah. So let's go ahead and make a guard. Mannequin. I don't know how to spell mannequin. Alright. Move my tablet out of the way. Alright, starter content. This might be one of the meshes. It's got some arms. That's not very useful. Character mesh. Yeah, it's not actually got a mannequin in this one. So we'll just put out. Do you guys want to backstab like a bush or a couch or something? Preview, like the preview material. Statue. What do you guys want to backstab? A chair. Okay. Alright, so here we go. We got a chair. And I will have it facing the view, of course. Get a little bit bigger. There we go. Nice big chair. Alright. And there we go. Let's perch it right on the edge here. And we will turn this into a blueprint. So I'm going to call this guard chair. Guard cherry. Yeah, that's actually a good name. Guard cherry. How about that? Yeah. It's a good name. Is the snowman still there? Oh yeah, we could backstab the snowman. That's true. That's fine. Let me.
I can decapitate a snowman.
Do you want to decapitate a snowman? Come on, it's time to play. All right. So we've got guard Sherry here, and I am going to add a blueprint to guard Sherry and just make it something. I don't know. Guard Sherry blueprint. Sure. Why not? Okay.
If you want to say cherry, you can just spell cherry.
I could, but it's a clever typo. All right, so one thing we can do is let's make it rotate in place. What do you guys think? Like have it be like a just a very simple sentry chair. Just spins around.
That's white one.
Rip guard cherry. Yeah, like that. Okay. And so we've talked a little bit about blueprints before. I need my arm, so I'm going to lecture. We've talked about blueprints before, and so the three most common entry points into a blueprint are these three nodes here. There are plenty of other ways you can sort of start a blueprint up. Stafford has the golden idol. Yeah. It's fine. We'll do guard Sherry. All right. So the three most common entry points are begin play, and so this will run one time, right? So if I had it print something like hello, it would print right at the beginning of the world and would not run again. So you typically use this to do things like set its health to be 100 and that kind of stuff. We're not going to need that. Begin overlap will happen like if we have a trigger sphere, like with the snowman, right? We had a trigger sphere, and if you walk into it, then it triggers the overlap event, and then you can have it, maybe attack and things like that. So we'll kind of put that off to the side for now, but we're just going to focus on event tick. So event tick is an event that takes place every frame of your game, and this is there's two big problems with using event tick, but we'll do it for now. Begin play is used a lot of times if you're just going to initialize something, or anything that you just need to have happen once, like the tick of a clock. Yes. So if you have 30 frames a second, event tick will trigger 30 frames a second. If you have a frame rate of 15, it'll trigger 15 times a second. And so one caveat is that if you let's say you move the chair 1 centimeter per tick, when your frame rate goes up, it'll start moving faster. So this is not good, and this is why a lot of games have bugs, especially when you uncap the FPS. All of a sudden, all the NPCs start running faster, rotating faster. The original Space Invaders is a lot more difficult on a faster CPU because it just runs as fast as it can, and so if you ran a game made for like a 286 on a 386, it would oftentimes run too fast. And so the 386s would actually have what's called a turbo button on the front of it. This is what the front of your CPU would look like. And if you unclick the turbo button actually didn't do anything, which is really funny. But if you unclicked the turbo button, that would actually make your 386 run at 286 speeds.
What's this?
It's for a car. It has nothing to do with what I'm talking about. And so if you unclick the turbo button, it would actually underclock your machine and have it run at the speed of the last generation for exactly this reason. So event tick is something that needs to be done with caution for that reason. And that's the reason why delta seconds is there. Delta seconds is there so you can normalize out the frame rate. The second problem with it is it's a performance issue. So if we have it print string, yes, girl. What's that? Can you watch TV? Sure. Go for it. See, so you can see that chair there is spitting out the word hello as fast as my poor frame rate can handle it. And printing a string is not the end of the world. It's not. You're not going to notice that performance-wise. But if you do anything costly, let's say like find all, whatever, search the entire world for something, right? get all objects within 2 kilometers, right? If you do that every tick, your frame rate is going to get punished for it. Punished, right? So event tick is not something you want to do with expensive things, right? But what we're going to do is going to be pretty simple. So we're going to do, let's see, rotate maybe. Let's see, what do we want to do exactly? Get what do we want to do? We want it to rotate in place. We want it to move up and down. What do you guys want it to do? Do you want the guard to rotate in place? Do you want it to float up and down in the sky? What do you want it to do? Float? Okay. So we will add relative location. And so what this will do is this will allow us to adjust the location. This is the translate that we talked about last time. Do you guys remember that? Translation, rotation, scaling. This is translation. So let's add every frame. Let's add, I don't know, 1 centimeter in the z direction. Let's see how that goes. Play. Do anything? Oh, yeah. That's why we need to make him movable first. This is one of the problems with Unreal Engine, is that a lot of times you do something and then nothing happens. And you're like, and you start going through all the different things. Like, all right, is this side? Is this side? Is it simulating physics? Is it generating collision events? You just sit there and start going through all the different reasons why things might not work. Let's try that now. There we go. So Guard Cherry is part of Team Rocket now, I think. All right. I learned that way. Yeah, it's fine. You're gonna make mistakes, and it's a normal part of learning. But it can be frustrating when you can't figure it out. You know what I mean? Translate is where you move stuff and not twist it or scale it. Yeah. So when I do this is translation. Okay. So let's just put him back over here so I can see. Cherry is more of a girl's name, so we'll see her. There we go. We'll rotate her this direction. There we go. Hit play, and there we go. So they're blasting off once again. All right. Okay. So we got some of that going on. Maybe we can make it random. Let's split it. So let's add somewhere between negative 10 centimeters and positive 10 centimeters every frame to that. Compile it. Did it work? Good. Save. Play. There. So it is randomly, Guard Cherry is randomly moving up, randomly moving down, and you can see sometimes negatives win, sometimes positives win. It's a little bit disturbing, honestly, watching that. It's like they're drowning in quicksand. A never-ending story. So, okay. That'd be cool for a saw. Yeah. It's. I mean, I don't really want to get too much into this because it's kind of not the point. But let's do backstabbing on it. So maybe just like when the player touches it, you know, with their nose, it'll do a backstab because we don't have a melee weapon implemented. So that'll be kind of the easiest way of doing it. This is a little bit disturbing. So if you wanted, and so if my frame rate went up, the thing would move even faster, right? And so this is bad coding, what we have here. And so what you want to do is take delta seconds and multiply that by whatever it is you're doing. So if you want your thing to be consistent frame rate, what you do is you take delta seconds and you multiply it, float times float, by whatever it is you're trying to do. And so now, rather than moving 10 up or 10 down per frame, it will be 10 up or 10 down per second. Did you guys hear that? So by multiplying by delta seconds, what that does is have the units be per second rather than per frame. So it's going to be a lot slower, right? Because you typically have 30, 60 frames a second. So things going to be a lot slower now. And so if I run that, you'll see it's very slowly. I don't even know if it's going to show up on Discord, but it's very slowly bobbing up and down. Very, very slowly. Let's see if I can zoom in here on this. See, it's very slowly moving up and down. But the movement rate of it is no longer tied to my frame rate. So if you do use event tick and you are going to be doing something like moving it and stuff like that, then what you want to do is normalize it based on the frame rate. And what that will do is have your object move the same speed, even if you're getting 120 frames a second or 10. Does that make sense? So you always want to do this. Because it's really bad. It's really bad when a video game behaves differently on a faster system than on a slower system, right? All the monsters run faster. You're like, no, I didn't pay for this. I didn't buy a 2080 Ti, man, so I could get killed faster, you know? And so you do things like turn up the detail settings to ultra so that everything slows down and the monsters literally run faster, run slower in the game, you know? That's bad coding. You always want to multiply by delta seconds, and you want to have these units be per second instead of per frame. So if I wanted to get it where it was before, I would say like negative 300, positive 300, assuming I was getting about 30 frames a second, which I don't know if I was, but play. And there you go. Now it's vibrating at the same speed it was before, which again is a bit disturbing. So, but it no longer is tied to my. It's no longer tied to my frame rate. So this is what you guys want to do here. And maybe I'll make it a little bit faster than that bobbing, and I'll just kind of leave it. Yeah, that's fine. Just kind of vibrating. That's fine. All right, it's good enough for that. Human reaction time is 0.25 seconds. Was that just a normal multiply node with the M shortcut? There's a lot of different multiplies. So drag out of a pin and then type star, and then it'll show you all the different multiplies you can do. And so what we're doing today is, well, what we did last time was vector times float and float times float, scalar times scalar, and vector times scalar. What we're going to do today, though, is dot product. And so what I want to do is say when the user touches the actor, I could do overlap. I could make a sphere trigger, but I'll do like if the player physically headbutts guard Sherry, then we'll calculate if it is a backstab or not. Okay, and so we're going to do this with the on hit event hit. There we go. So event hit gets triggered when somebody hits it. I don't know, it's pretty advanced. One thing you do have to check is over here in the details, does it do generate overlap events, simulation, generates collides, generate overlap events, block all dynamic. Let's see, collision presets, block, generate, collision response. project. I don't think we need to do that. No, we don't need to do that one. I don't think either of those are necessary, but I'm going to try it anyway. So, again, the most common bug you get in Unreal Engine is you do something and nothing happens. And so sometimes it might be a problem like 3 levels deep, like a parent doesn't have hit events enabled on them and things like that. Let's see here. Yeah, it should be fine. Okay, let's see how that works though. So when we get hit, we are going to print a string, and let's print the string of the person that hit us. So hits are kind of complicated. We can go through this in a little bit. This is me. This is my part that got hit. We're only a chair. And so this isn't really needed, but sometimes you can have like, I don't know, let's drag a cube out. There you go. There you go. I'm just a chair. Oh, okay. There you go. Guard Cherry has a head now. I don't know. So you could do things like, you know, headshots and things like that, right? And so a lot of times you want to know, like which component got hit. Yeah. And so that's available for you. Simulation generates hit events, physical material override. Yeah, that's cool. Smart water. Right, none of this really matters. There. Okay, so yeah, you can have different components. There you go. So there's a head now, in case you want to headshot that. So anyway, so you can figure out what that is from here. For right now, all I'm going to do is get the name of the. Let's see if that'll work. Yes, good. I will get the name of the person that hit us. Okay. So when Guard Cherry is hit by something, it is going to get the name of that object in the world, and it's going to print it to the screen. And you might notice what I did there. This is a purple or a fuchsia color. Everything in Unreal Engine is typed. In other words, there is a color-coded type system in Unreal Engine, so you can just kind of look at something at a glance and know that blue things are actors. The kind of yellow-orange is a vector, red is a Boolean, that kind of stuff. It will sometimes do conversions for you. So if you drag from an actor into a string, it'll actually just get the name of the actor. And that's really nice. It's a very convenient thing. You don't have to remember how to do that. And then if we come down here and hit play, you will see that it is vibrating in the air, and there we go. And so when I touch it, it prints first-person character to the screen. You guys see that? Okay. All right. So, can you use an Xbox controller with the UE4? I'm sure you can. Yeah, I don't see why not. Windows has Xbox support. Okay, so cool. All right, so that worked. So we don't need that now. The first thing I always do is that. Like whenever I'm doing Unreal Engine development, I always just start off by printing a string just to see if it works. Because if I didn't check a box somewhere, then nothing would happen, right? And so I always start with that. You always start small, go slow. You know, is always good advice. And so first person, was it first person character? Was that the type that it said? Do you guys remember? First person character? Was it? Let's say it was. So I'm going to do the same thing now, just a little more sophisticatedly, if that was the right type. Yeah, okay, good. So this is casting. So casting is, it's from computer science, and what it means is you're trying to convert from one type to another. And so what I'm doing here is I'm converting from the actor type to first-person character. So if I shoot this chair with the ball is not a first-person character, and it doesn't print anything. See that? So there's two possibilities when you do a cast. Either it succeeds, in which case it prints hello, or it fails, in which case absolutely nothing happens. So what I'm doing here is I'm saying only accept hits from players. Do you guys see this? Like, it looks like the same code as before. It's printing something when I hit it. But what it's doing, it's very clever. If a box hits it, or an ocean hits it, or a ball hits it, it will not cast to first-person character. The casting will fail, and I'm not doing anything, so just it ignores it. So what this code is saying is ignore all hits from anybody who's not the main character. Okay. So this is a more sophisticated way of doing it, because I don't want random, bushes falling on it and causing it to print. I'm backstabbed, So what I'm going to do, now that I know the player has touched the guard, what I'm going to do is I'm going to get the forward vector, get the up vector, get the forward vector of the which option? The camera, the gun. These things don't always point in the same way. Who should I get? Let's say the camera. Okay. So I'm going to grab the forward vector of the camera. Do you guys see that? So like that's the direction the player is looking in. And this is not exactly yeah, I guess it's fine. Because technically you can walk backwards into the guard. It'll be fine for now. What we'd really want is the user has to hit a button, and let's not worry about that for now. So we're going to get the forward vector of the person, and remember this is relative. This is in local coordinates, right? So whichever way the player is looking, the forward vector is the direction they're looking, right? And what I'm going to do is I'm going to get me. So I'm going to get maybe the chair. Which way is the chair looking? It's looking in the X direction, I guess. Okay. Okay. So I'm going to get, yeah, I'll just get me, and I'm going to get my forward vector. Okay. So remember how when we were in OneNote, we were talking about the forward vector of the vending machine and the forward vector of the player? You guys with me? That's how you get it. So it's just called get forward vector. You drag it out of any actor, you can get the direction they're looking. Warning, not all objects are facing in the direction they're supposed to be facing. So there's a problem in Unreal where sometimes the right vector is the forward vector, and I don't know why. It's just because you can rotate these things however you want. Like I could come in here and just I could just rotate the this thing. I could just be like, yeah, it's there. So the way that the artists put things in the world don't always like there's mannequins where the forward vector is coming out of their shoulder, right? And so you just kind of have to adjust for that if that's the case. Anyway, so we got our forward vector, we got the guard's forward vector. What's our next step? What do we do if we want to see if we're going to backstab the guard? What's the next step? Figure out the dot product. Very good. So I am going to right click and choose dot product. And dot product XYZ, dot product. There we go. Boom. And you see how this is all color-coded. The yellow gold color is a vector, 3 vector. And so I just do that, and it gives us a green, a float, a number from -1 to +1. If these things are normalized, which I certainly hope they should be. If they're not, then I'll have to normalize them. How do you normalize something? What do you guys think the note is called to normalize something? Any guesses? To normalize a vector? Anyone? Normalize. Right. So you can normalize a vector that way if you need to. We'll find out very quickly if they are normalized or not, because you'll get a dot product not between -1 and 1 if they're not normalized. Okay, so now that we've got the dot product here, let's see if we can zoom this around over here. And zoom. Okay, so now we need to do a, let's just print it. Let's just print the result. Print string. Let's just print what the backstab value is, right? Move you guys left a little bit. And if you drag from a float into a string, it will convert it for you. The little dot thing here is the casting. It's a shortcut for casting. So it's going to cast between a float and a string. So we'll print out the string and call it a day. So come in here, hit play. And if we walk up and hit it, you can see that we're getting a number very, very close to 1. Do you guys see that? We're getting a number very close to 1. What does that mean? What does a number close to 1 mean? They are facing away from us, correct. Or another way of putting it is the guard and I are looking in the same direction. Okay? We are looking in the same direction. Because it could be like this, right? I could walk backwards into it, right? Backwards into it, and it's still 1. That's why I was saying, like, because I don't have the button hit with a trace line, it's actually possible to backstab the guard from the front like this, which... So, yeah, and so basically, there you go. And if I hit it from the side, what number do you guys think I should get if I'm going to run into Sherry here from the side? Around what number? Floats, you never know exactly what you're going to get, but it's like a box of chocolates. What do you guys think? If I bump into it right now. We get 0, or very close to 0. Remember, 0 means perpendicular. 0 means side shot. Okay. And if I hit it from the other side, I get a positive number in this case, but it's still very close to 0. Right? So if I run into it like this, you can see the numbers are very close to 0. So 0 means you are at 90 degrees-ish. Right? All these things are ish. Whenever you're working with floating point numbers, you're never going to get 1. Right? I got 0.99. That's pretty good. Right? It's very unlikely to get 1. Yeah. 0.995 is pretty close. Okay. No, we don't need the idle. It's fine. It's we got guard Sherry here. It's a member of our team now. Okay, so 0.05, and then if I hit it from the front, what number am I going to get? About. But thank you for offering the golden idol. Precise positions are not easy to hit. Yeah, that's actually a really good takeaway point as well. Don't ever use equality, right? When working with floating point numbers, don't ever expect a number to be 1. Right, you always use greater than, or less than. Okay, so whenever you work with floating point numbers, you use a range, right? So numbers that are near 0, numbers that are near 1, right? You never use double equals, never use equality. Okay, so Jerry thinks we're going to get a number near 1, and the answer is -0.1. 0.99. We are facing the wrong way, or we're facing the same. We're facing opposite directions. If you face in opposite directions, you will get a negative 1. If you face in the same direction, you will get a positive 1. Okay. So that is dot product, and that's kind of like why I like demonstrating this in Unreal Engine, is rather than trying to remember a bunch of rules, you can just be like, all right, look, there it is. If I hit it from the side, I get 0. If I hit it from the back, I get 1, or close to it. If I hit it from the front, I get negative 1, close to it. Okay. So if I want to implement backstabbing, then I need to say if this number is close to what? If this number is what? What do you guys think for backstab? Give me a range. Give me a range of values for backstab. .98 to 0.99. Not 1 if you're perfectly lined up. If you're perfectly lined up, it doesn't backstab. 0.5 to 0.1, 0.6 to 0.1. All right, I'll go with Stafford. So we'll do a greater than, and so we're going to compare a float, and whether it's float greater than float or float greater than equal to float, it don't matter none, because you are very rarely going to actually get two floats equals to each other. So we're going to say if the dot product is greater than or equal to 0.66, execute order 66. If the dot product is greater than or equal to 0.66, then we will print. And again, I always start with printing just to make life easier. In reality, I'd have it do damage and maybe an explosion or an or something like that. But I'm just going to have it say backstab. Okay. Come in here. And if I hit it from the side, no backstab. If I hit it from behind, backstab. Backstab. Not a backstab. Not a backstab. Maybe it should be backstab. I don't know. You tell me. Not a backstab. 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 So that feels pretty good. Yeah. Backstab. No, not a backstab. Not a backstab. Not a backstab. Backstab. Okay. So it's always good to have logging and breakpoints. Sure. Yeah. Yeah. Just printing strings is just the easiest way of doing it. And then I delete it once. Once I'm happy with it, I just pull it out, and I can always put them back in it later if I want. It's just a really easy way of testing things, you know. All right. So let's go ahead and save all that. 0.66 is around 2/3. Yeah, but what is that in terms of degrees, right? You have to fire up yield scientific calculator, 0.66. So we are doing 48 degrees to either side. So it is 90. It's a 97 degree arc that we are backstabbing in. Okay. And if we want that to be bigger, we can adjust the number. Like if we want to go with Lave's 0.5, like that, then that's a backstab. That's a backstab. Right, so we're getting wider backstabs now, right? See that? So that backstab that wasn't a backstab before is now a backstab. And so that's right on the edge there, okay, of the new one. So we widen the arc of the backstab. Okay? So that is dot product. And that's used all the time. Right? All the time. You want to know are two cars driving in the same direction, right? Is a car driving at me? That's a good one. And so you can, is the car driving in my direction? And this is used in a lot of video games to determine if, and it's bugging out again. Well done. One note, well done. Your high quality product. There we go. So let's say you've got a car. Car is driving in this direction. And you are a pedestrian on the street here. It's the edge of the street. Doesn't matter which direction you're walking. And you want to know, is that car going to run me over? This is used in a lot of video games, right? Like Grand Theft Auto, right? If you drive your car off the road, then the people will throw themselves out of the way, right? So how do you determine if the car is coming for you, right? Maybe you have like a fairly narrow angle, right? Because you don't want it activating out here, because then it's going to be like Cyberpunk, where like the pedestrians scream and run if you're just driving down the street, because it's, yeah. So, like probably a pretty narrow theta, like greater than like 0.9, I don't know, something like that, right? But how do you do it? Like you've got a look vector, you've got a forward vector here, right? You got a forward vector, and then you've got a position of this person, you got a position on the car. So how do you do this using the powers of linear algebra? How do you tell if the car is driving at you? Pedestrians do disappear in Cyberpunk as well. Yeah, you look away, you look back, and there's different people there. It's all a glitch in the matrix. So what do I do? I'm asking you guys. If you want to decode this in Unreal Engine, how would you tell if the person is within that little arc here? Because the person could be here, the person could be here, the person could be here, the person could be here. How do you determine if the person is actually, that's the person. How do you determine if the person is within the forward, I don't know, 15 degrees of the car or not? You need to use dot products, yes. You do. But the dot product, we got a forward vector, but does the direction that's eraser tool. Does the direction the person's looking matter? This is a different one. If the person's looking that way or that way, does it matter if they're going to get run over? Or not? It doesn't. Their forward vector doesn't matter. What we need to do is figure out this. How do we get a vector from the center point of the car to the center point of the person? We learned this last time. How do you get a vector from point A to point B, or vice versa? What's the linear algebra way of getting a displacement vector? Yes, very good, Dolan. What do you do to get a displacement vector from B to A, let's say? What is our tool in our toolbox to do that? Find the coordinates of each one. Yeah. So A is, let's say, the origin. A is the position of the person. B is the position of the car. What do we do to get a vector from one to the other? Subtract them. Very good. So we take A minus B. Then what? So that gives us a vector maybe of length 100, right? From B to A. So if we take A minus B, that is a displacement vector. That is the position. It's 100 units away that way. How do we convert that into it? How do we normalize that? We feed it into a normalized vector, because we're going to do this in Unreal Engine. You divide by the length, right? Divide by the square root of So in Unreal Engine, you just use the normalized node. It's easier. So rather than using the forward vector this time of the person, we are going to let's see. So what do we want? We want to, let's say that Cherry is going to honk. Let's pretend Cherry is a car now. Whatever. I don't want to draw a new model. We got 4 minutes left in class. So let's have Cherry just honk if somebody is like directly in front of her. Okay? You guys understand? So in games like Grand Theft Auto, the pedestrians will use this to, you're coming right at me, and they'll do this, and they'll dive out of the way and stuff like that. But But for now, let's have it be the driver instead of the pedestrian, and the driver will just honk if you get in front of Cherry. So we've got the look vector of Cherry, cool, and now we need to get the position of the player and subtract it from the position of Cherry. Okay, so let's get the first person character. Let's move all this up out of the way. All right, so we got the first person character's location. So get world location. And so we're going to get the location of the camera. That's your eye, basically, in the world. So we're going to get the location of the player. And then we are going to get the location of the Cherry. Get world location. Get world location of, yeah, the head, whatever. So we're going to get the location of the head. We're going to get the location of the player. And as Dolan said, we are going to subtract them. So this is going to be vector minus vector. So I plug in vector A, subtract out vector B, and that gives us the displacement vector from B to A. And so one thing we could do is take the length of this and have Cherry not honk. Like if they're a kilometer away, there's no reason to honk, right? So if they're within, I'm not going to worry about that for now. Let's just do it if they're in front, okay? So this is this right here. So we've taken the location of the player, we've taken the location of Cherry, we've subtracted them. That gives us a vector from Cherry to the player of length 100 or 200 or whatever. So what we need to do is normalize that. So we're going to feed this into a normalized node, like that. And that gives us a unit vector pointing from Cherry to the player. We feed it in here. Dot product, sorry. We feed it into dot product, sorry. There we go. And then, what threshold should we use for Cherry honking at us? What do you guys think? So what dot product should we use for this, right? What numbers should we use? -7 to -0.99, not -1. You're excluding -1. If it's perfectly behind the person. All right. All right. So if it's all right, let's do that. So let's say less than or equal to what did you say? Negative -0.7. Okay. -0.7. -0.7. So if it's less than -0.7, then we shall honk. And in reality, you would have it play a sound and maybe have the AI steer around or something different. But this is just to demonstrate how the math works. So we compile it, we run it, and nothing is happening. Oh, there it is. Problem. Okay. We'll bypass the branch, and we will just print the dot product. So we're going to be computing the dot product here every time, and see what we get. Oh, it's only right. It's only running if we touch it. Right. That's what the problem is. So this is part of the event hit node, right? So this code's only running if we hit it. So what we're going to do instead is we're going to just run event tick right into print string. Actually, we can have cherry still vibrating up and down, and we'll do that. Okay, so yeah, that'll be fine. So every frame it will print out what the dot product is. There we go. So currently we're at -5 and -5 and -5, and it does not seem to be changing. It's because this is no longer allowed. Because we're not doing this anymore, right? Okay. So we need to get the player. Okay. So let's get rid of this event hit thing for now. Let's just cut all this out. So we no longer have you. So all that's gone. Just throw this over here. And so we need to get the location of the player. So how do we do that? Because before it was easy. If you run into Cherry, you can get who the person who ran into you was. So how do we get the player without it? Oh. Get player by get my player index, get player display name, get player pawn, I think should work. Player 0, that's the first player in the game. We will get the world location of the root of the player. So this is how you get a player. In multiplayer, it gets more complicated. In single player games, you just get player ID 0. That's always the first player. And then you can see here, -9. We walk around to the front. +9. Okay. 0.1. 0.0. So a threshold of, let's go back in here. Let's put this back in here. Okay. And so let's put this back in here. And so we're just going to honk if the person is in front of us. However, the threshold is not right. As we saw from running it, the threshold should actually be positive, right? So it should be +7.7. Yep. So we compile it, save it, and here we go. So it's no, actually, I think you're yeah, I think you're right. I think it was negative. Okay, let's go back in here. Depends which order you do the operations in. Oh, less than 0.7. Right, that's wrong. It should be greater than 0.7. Okay. So if I walk around in front of Cherry, it starts honking at me when I'm in front of it. And then when I walk off to the side, it ignores me. Right? You guys see that? So that'd be an example of a very simple way of telling if somebody's in front of a car. So it's what we did last time, subtracting 2 positions, normalizing it so we get just a direction from us to them, and then you dot product them. And that dot product will tell you, are they in front of us? Are they behind us? Are they to the side of us? You guys understand? That's kind of the lesson for today. Let's see if I can clean this up so it's all visible on one screen. good enough. Here, I'll screenshot that for you guys. All right, so this code here will put on Discord. So this code here will tell you if the player is in front of an NPC. Okay. And that number here is the threshold, right? That's whether the guard will say the person's in front of me is a narrow angle, a wide angle, super wide angle, whatever. Okay? You guys understand? That is the dot product. It's kind of pretzeled up right now. Unpretzeled. Is that better? So you difference the positions to get the displacement. You normalize the result, dot product it with a forward vector, and then you say, is it greater than some number? And that number controls how wide you allow the person to be in front of you. Let's try that one instead. Delete the other one on Discord. Any questions? That's basically our lecture for today. I know there's a lot you can do with it. The question is whether or not, can I not delete that? Can I not delete the old one? Delete. Message. Here. So do you guys see how useful that is? It's one of the really, really important basics of video games. If you want to make a rocket launcher that follows a laser dot, right? You got, dot product is used. Is the laser dot in front of me? If it's not in front of me, I can't see it. Like if the rocket's flying around and you snap the laser behind it, it can't see it anymore. It loses sight of it. Knowing if something's in front of something comes up all the time. You're making a sentry gun. Sentry gun's rotating around like this, rotating around. If we want to do that for guard Sherry, rather than adding relative location, we could add rotation to it so it's spin. Right? Sees the enemy. Instead of honking, it starts shooting. Same idea. Okay. Comes up all the time. So I'll put up a little quiz on this, I guess. Maybe, or do you guys just want to do this? Do you guys want to make a guard? Make a guard that will print halt, 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 quiz. You'd prefer math quiz? Okay. Make a guard is more fun. The guards in Daggerfall just shouted halt. Murdering spree.
Halt! 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 Halt!
Elder Scrolls 2.
Halt! 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 Halt!
You could probably implement that. Right? You guys know how to add a sound to the Unreal Engine, right? We went over that before. So rather than printing a string, just have it yell halt. You want to make a guard instead of a quiz? Okay. All right. You guys want to do that? Like a Daggerfall guard that just shouts halt if you walk in front of it? Does that seem reasonable? Or print. I guess you could just have it print a string also. If you're going to screenshot it, it's kind of hard to tell if you play a sound. that sound cool? It's basically going to be you recreating what I've done here. So, yeah. Por qué no los dos? Screenshot your speakers. Yeah, right now it's playing Halt over and over again. Okay. Why not both? You want to do a... Sure, I will put up a math quiz as well. There you go. Free points. All right, well, that's it for today, guys. Thanks for coming out, hanging out, participating. Audience participation is always important when doing game design. It's a very boring class if nobody shows up. So, yeah, I'll put up the assignments on Canvas right now, and I'll post this video. So you guys should just be able to just follow along and get it to yell halt if you walk in front of it. Maybe find a better guard than a chair. I don't know. Either or. You want to do either the quiz or the... If you fail the quiz, you have to make a guard. Nah, I don't know. Maybe. I think making a guard's more fun. So we'll do that. Okay. That's it for today, guys. Thank you very much. And both for extra credit. It's pretty basic. Yeah, what we're learning here is the mathematical basis for video games, and I don't think it's too bad, really. Okay. All right, I'll see you guys later. Fun hanging out with you guys as always. Take care. Get your shots if you can. It's March now, and so if you work for the school, you can get a shot. I got my first shot yesterday for vaccine, so by the end of the month, I'll be able to actually go out in public again and stuff like that. It'll be cool. Probably get sunburned, who knows.